So now we're talking about the library, the Arduino library that supports I2C. So that's called wire. So the wire library is used to access I2C. Why they don't call it I2C, I'm not sure. Maybe it's the lease name or something. I don't really know. Maybe it's copyrighted. I don't know. But the wire library is what accesses I2C. So first, to start off using library, like with all libraries, you have to start off with a hashtag include, with the appropriate hashtag include. In this case, it's wire.h. So that's the header. That's the header file. So you put that at the top of your file. Then to initialize the library, to start off all the I2C operations, you got to call wire.begin. And you would do this in your setup. This initializes the I2C hardware. So in the microcontroller, the ATmega328, it has hardware dedicated to I2C and dedicated to basically doing all the stuff, creating start condition, stop condition, all that. And so that hardware is initialized by calling wire.begin. Now, if you call wire.begin with no arguments, that makes the Arduino the master. But if you call wire.begin with an address as an argument, some number between 0 and 127, then that makes the Arduino a slave, and its address is whatever the address argument was. So if you don't pass it an address, see, masters don't need addresses, right? Masters they need addresses to talk to slaves, but if you're not a slave, you don't need an address. So if you give no address, then you're a master. Master communication. So here's a really rough, high-level overview of what your communication will look like from the master point of view. You start the communication, you send a bunch of data, and then you end the communication. You start transmission, you send data, end transmission. And so there are functions for each one of these things. So data, one thing to note is that data is put into a buffer before sending. So what I mean is inside the ATmega328, there is a buffer for the I2C data that you're going to send. So it's not like, basically all the data that you're going to send gets put into this buffer, and then it's all sent out at once. The whole transaction is done at once. Basically the whole buffer is dumped onto the lines. So when I say dumped onto the lines, say you want to send 10 bytes. So all 10 bytes are put into a buffer, and then when you end the transmission, when you call end transmission, it actually sends those 10 bytes on the SDA and SCL lines. So it doesn't happen as you call it. It happens when you end the transmission. So you start off, you say wire.begin transmission address, and this initializes it, tells it to do it. It's going to have to do a start condition, and tells it what the address is. It's going to be sent. What those 7 address bits are, those are whatever the argument is. Those are going to become the 7 address bits. Now, then you say you write data. Wire.write, it basically writes data. So you give it a byte, data is a byte, and that's going to be the data that's going to be transmitted on the bus. And end transmission, it basically that transmits the data in the buffer and creates a stop condition. So when you call end transmission, it takes all the data that you wrote into the bus, it creates a start condition, it sends the address, then it sends all the data in the buffer, and then it creates the end condition. So that's so basically all of your transmissions are going to happen like that. There's going to be a begin transmission, then a bunch of writes if you're doing write transaction, and then an end transmission. And that's it. It's pretty straightforward from a coding point of view. So here's an example. Let's say I define my address. I do a hash define up there. Address is equal to 1, right? So that's the address that's the slave address I'm going to send to. So in my setup, I say wire.begin to initialize the I2C hardware. Then wire.begin transmission to the address. Then I'll say wire.write 2, wire.write 3, so I'm sending 2 bytes, 2 and a 3. And then wire.end transmission and stop, and that just causes all the data to be sent in the format that we talked about in I2C. So from a coding point of view, you don't have to worry about all the details, the bitwise details of, is this bit a 1, is this bit a 0, all the sequence stuff. And I talked about that, but that stuff, as a programmer, you don't have to think about that all the time. You can call these library functions, and it will handle all that for you. So this sends 2 bytes and sends the start condition, the stop condition sent at the end and start condition at the beginning. Thank you.